We want to solve for cotangent of 2x equals -1, finding exact solutions on the interval from 0 to 2 pi. The first thing I'm going to do is figure out where, I can kind of think of this like a theta, where is the cotangent -1? And if I think about it, for cotangent to be negative, I could be here in quadrant 2, where the cosine is negative and the sine is positive. This is at negative square root 2 over 2 and square root 2 over 2. And also down here in quadrant 4, where the cosine is positive but the sine is negative. Because we know cotangent of theta is cosine over sine. So those two places would give us -1. And so those angles would be when theta is 3 pi fourths, or when theta is 7 pi fourths. Now, if we wanted to write all solutions, that would be when theta was 3 pi fourths plus pi k, because if we add pi, we're around to this solution, then add another pi around to this solution, and so forth. Now, we didn't have theta, we had 2x, so I'm going to replace the theta with 2x. That's 3 pi fourths plus pi k, and I'm going to solve for x, so I'm going to divide by 2, and I need to divide this by 2, and I also need to divide that by 2. So all solutions would be x equal 3 pi eighths plus pi over 2k. And I don't need all solutions. I'm interested in the ones between 0 and 2 pi. Normally around the unit circle, once there'd be 2 solutions, when we put a coefficient in front, that would double those. So we need 4 solutions. The first solution then is going to be 3 pi eighths. That would be when k was 0. Now when k was 1, we would add pi halves to that. And pi halves, if we make that into eighths, if we multiply by 4, is 4 pi eighths. So I add 4 pi eighths and get 7 pi eighths, and that's my second solution. I add another 4 pi eighths to that, 11 pi eighths, my third solution. Finally, I add another 4 pi eighths to that and get 15 pi eighths, my last solution. Now, if we didn't realize that was the last solution and we added another 4 pi eighths, we would be at 19 pi eighths, and that is larger than 2 pi, which is 16 pi eighths. So here are my 4 solutions between 0 and 2 pi.